Welcome to this WebSphere Technical Exchange. My name is Paul Brett, and the subject of this video is 12 common pitfalls using Transformation Extender and how to avoid them. Throughout this video I will refer to the product as TX, and these techniques apply to all current versions, be they named WebSphere Transformation Extender WTX or IBM Transformation Extender ITX. In this video I'm going to highlight a selection of common pitfalls which you, as a TX developer, might encounter, along with tips on how to avoid them. My apologies to Alan Fluff Freeman. Okay, pop piggers, let's start running down the top 12. In at number 1, we will tackle the thorny subject of functional maps. Running a close number 2, adapter connection anomalies. New at number 3, XML Schema considerations. A non-mover at number 4, that classic pair, adapter not found and unknown error. Number 5 sees us take a quick look at the Unix setup script. 6 rounds off the first half with a quick word on third-party client software bitness and shared library path shenanigans. The fun continues at number 7 with some tips on launcher administration. Rising fast at number 8, we have adapter appropriateness. Number 9 sees the return of the functional map, this time a quick word about iterations. Installed at number 10, yes, it's those pesky patches. Right on time at number 11, the launcher and some triggering tips for users on the Windows platform. Rounding out the chart at number 12, possibly saving the best till last, XML Schema validation. Okay, enough agenda nonsense, let's move on. Here we have a typical, if slightly simple, functional map call. The arguments in brackets are separated by commas. Here we have 2. If a functional map call has 2 arguments, then the functional map itself must have 2 input cards. Each input card root level type tree object must match those arguments. So my first argument here, date item, is the same entry I would have for input card 1 of the functional map for the type tree object. As you will probably know, all functional maps have only one output card. The root object of the only output card in the functional map must match the type tree object where the functional map call is made. Let's see that in the map designer. Okay, so here we have the map designer, and we have our executable map, which is called blob. We have one input card with 2 input objects, date item, time item. And as you can see, the object properties are defined appropriately. CCYYMMDD for date item, and a 24-hour time format, no colons for time item. Here's our functional map call. 2 input objects, separated by comma, date item, and time item. Name of the functional map is functional map, so let's have a look at that. As you will see, we have 2 input cards, in 1 and in 2, and each one uses the type tree object appropriate to the input object that was in the functional map call. Date item for in 1, and over here in 2 we have time item. On the output side, you will see that the type tree object used in the properties for that card, date time item from output.mtt, match exactly with the type tree object where the rule was placed that actually calls this functional map. The TX product has grown over the years, evolving through several name changes. The quantity and variety of the TX adapters has also grown and evolved, which on the whole is a good thing, but has led to 1 or 2 connection string anomalies. For example, using the database adapter, one would use -pw or -password as the command line modifier to specify the password. On the email adapter, however, the same argument is specified with -p or -pass. Sticking with database connectivity, you will find that the Oracle adapter uses -c or -connect command line option, whereas every other database adapter uses -ds or -source. The SAP ALE and JALE adapters have gone through some changes recently, but we're now standardized on -g meaning gateway host and -group meaning group. Previously, and rather confusingly, -g was used for both. By the way, for the IBM WebSphere MQ adapter, -grp is used for group. I'll finish on this slide with a recommendation to check the documentation where possible for the correct adapter modifiers to use. Okay, so here we are back in the design studio, and I just wanted to show you what would happen when using one of the modifiers incorrectly. Here in the map utility.mms, we're doing a get from the database adapter with db type, connect, user, pass, t for trace and statement. However, pass is an incorrect option. It's supposed to be password. You'll note that I've added last error message onto the end of the rule there. That's so that I get more information in my output.txt file when it gets produced. Okay, so let's run this map. The map completed successfully. It would have been better if it failed. It would have done if it was wrapped in a valid fail pair. The output.txt file just says failed to connect to the database, and if we go and look at the database trace, that echoes the same thing in the last line. You'll note there is a password mask there, but that line always appears. The real giveaway clue here is null password given, logon denied. It's not very obvious, but what it's telling you is that you haven't actually specified the password option, and instead you've used pass, and it doesn't work. There are 3 XML parsing methods available to TX, and it is sometimes confusing which ones require the XML schema to be available at runtime. When importing an XML schema using the classic importer, the resulting type tree will allow XML validation without reference to the schema at runtime. Both Xerces and native, that is using the XML porter with the Xerces option, or using the XSD directly in the card properties, will require access to the XML schema at runtime, unless of course the Xerces well-formed option is activated. When executing on the ZOS platform, it is important to remember to transfer the XML schemas in binary mode. As they are UTF-8 data, this usually means that they will be unreadable using a 3270 access terminal in ISPF, but they are then correct for TX use. If the map is for the ZOS platform, then the card should use the //dd : syntax, followed by a label such as schema or some other label of 8 characters or less in the input card. The JCL will then contain a DD declaration pointing to the same label, which then onward points to the real file on the ZOS file system. Time for another quick demo. I'm going to show you what happens using each of the 3 XML parsing methods, both with and without the XML schema file being available. On screen we have 3 windows. Top left you'll see the window displaying the audit log, on the right a window displaying the trace, and finally a command prompt window. I have 3 maps: test1 classic, test2 Xerces, and test3 XSD. The schema file is in place, so let's execute each in turn, starting with test1 classic. I'm going to be using the command server. I'm using the -B option to avoid a pop-up. Okay, so test1 has executed. You'll see the audit log is there showing map completed successfully. Trace is on the right showing nothing interesting. Let's execute test2. Okay, test2 has executed. You'll see the audit log changed. It shows again that map2 completed successfully, and on the right you'll see the trace changed. It's a lot shorter for the Xerces schema, Xerces parser. Let's fire up test3. And again, you'll see that the audit log has changed to show the test3 map has completed successfully. Okay, so let's get rid of the schema. I'm going to do that by renaming it temporarily. $$ is fine. Okay, and I'm going to re-execute the maps in turn. Let's start with test 1. As you can see, the audit log shows that test 1 is showing again map completed successfully still, i.e. the schema is not required. There's been no problem. Moving on to test 2. Okay, on the input side you will see that the audit log has changed to show that test 2 is executed, and it's showing XML parser invalid metadata location, information that is also repeated on the trace file. And let's switch to test 3. Okay, the audit log has updated to show test 3 executed, again showing invalid metadata location, again repeated in the trace file. Both these messages, the 59s and the 305, sound a lot more serious than they really are. In both cases, what it really means is that the adapter could not be initialized for some reason. Those reasons vary, but the things to check, in no particular order, are 1. Is the adapter actually installed? It is possible to install TX with a subset of the adapters, and the adapters.xml file should be checked to see what's actually there. 2. Can the third-party software be located? Now obviously this does not affect every adapter, but take the SOAP adapter for example. It is essential that the m4 soap.jar file be in the correct place for the execution environment for this particular adapter to work. I recommend that you use the LDD command on the Unix command line to identify missing third-party libraries. The equivalent utility on Windows is the depends.exe utility, available from Microsoft. Further details on these utilities can be found in the tech notes regarding these. Links should be posted with this video. For the 305 specifically, I recommend that you use the JNI layer trace option in the dtx.ini file to create a JNI layer trace that will help to resolve this particular error. The Unix setup script can be a tripping point for some. My recommendation is that it should always be run manually after every other command, such as those in the profile, have finished. If it really must be added to the profile to avoid being missed altogether, then it should be the last entry. If for some reason you're getting different results in different execution environments, say the command server and WebSphere message broker, then I recommend using either the BAT or the shell adapters to check the in-process environment variables. Get the results from 2 runs of a map with a get rule in there, such as get bat and the command/c set option, or get shell and the set option, along with get shell with the env option, and compare these side by side from the 2 environments to check for missing or altered entries. This is kind of linked to point 4, but I believe I can pinpoint further potential tripping points with both client library bitness and location-related environment variables. TX adapters connect to local clients via libraries, which are located by the parent process using the entries in the shared library path in the order that they are specified. The bitness of those libraries must match the bitness of the parent process, i.e. TX. So, a 32-bit Oracle client will not initialize from a map using the Oracle adapter if the map is called from a 64-bit TX launcher. As mentioned before, use either LDD on Unix or again depends.exe on Windows to check for bitness mismatch issues. When using IP, sockets or pipe communications to remote or even local server listeners, the remote software need not match bitness. The example shown at the bottom is where TX on a 32-bit Unix platform communicates through the local Oracle client, which must be 32-bit also, with a remote, or possibly local, server, the bitness of which is unimportant. Another quick demo here. What we have here is the Design Studio. I have a map open and it is set to read from the Oracle database. In this case I'm using TX841. This is a 32-bit Design Studio. I have the 32-bit Oracle client libraries on my machine. So let's execute this map. Okay, the map completed successfully. Clear the OK button and you can see we have the audit log confirming that the map completed successfully and the adapter trace has been populated saying that the connection was successful. Okay, here I have a command prompt window where I've deliberately set the environment variables such that it cannot find the 64-bit client libraries. It will be able to find the 32-bit client libraries, but because I'm executing from a 64-bit command server here, DTX-CMD64, you can see that this is basically not going to work. There we go, we execute, we get a pop-up message. Let's clear that. And then you get another pop-up message, both of them complaining about DLLs not being available. And when we switch back to the Design Studio, you will see that the log tells us useful information such as source not available and failed to load the shared library. The adapter log shows us the same information. Error message from Oracle 1027 failed to load the shared library. Sorry, the error message not from Oracle there, from TX. After a fresh installation of the TX launcher, it is essential to run the launcher admin program at least once. This will ensure that the required launcheradmin.bin file is created. I recommend that you add at least one user and, if appropriate, and it usually is, the default ports should be changed as well. Recent under-the-hood changes in the format, content and structure of the launcheradmin.bin file means that a migration or patching event may leave the file unreadable by the launcher processes. The same goes for the mgmt console.bin file and the management console process. In these cases, it is best to export using the command line options shown before the migration or patching event. The exported XML file can be re-imported after the migration or patching to ensure that the required values are preserved while the underlying format, content and structure is correct. During the early stages of the mapping process, getting your map to actually collect, collate and present the information you want, it may be prudent not to use the eventual adapter. Say for example your input is a remote database and the query you have designed retrieves 500,000 rows. It may be better to turn on the backup option and get a local copy of that data, the rows of which can then be trimmed down in quantity as required. You can then temporarily use the file adapter for a quick build, run, review, change, build, run again cycle. Getting close to production, be mindful of the size limitations of some of the utility adapters. For example, the tar and gzip adapters are incredibly resource intensive, and a call, using the batch or shell adapters, to the command line versions of the archiving routines might be more efficient. Conversely, you might need to think about target limits. The email adapter, for example, would have no problem with dealing with a 250 megabyte attachment, but can you say the same for the target email server and the clients that intend to connect to them? If during your TX map testing you're getting frustrated because it looks like a functional map is not running, I recommend you check those input object counts. The functional map will be called for each unique iteration of a combination of those arguments. So, if you have 2 arguments, each contains a 4 count, then the functional map will execute 16 times. In the functional map call listed on the slide, If the number of rows in in3 is 0, this functional map will not be called, because 15,000 times 1 times 0 is still 0. Use the count function on each of these arguments to check for items that have a 0 count, which are preventing your functional map from execution. Let's have a demonstration of that count technique. Okay, here we have the Design Studio, and I've got a map with 3 input cards, in 1, in 2, in 3, each with a repeating group. On the output side, I've got a functional map call that sends those repeating items down as arguments 1, 2, and 3. In the functional map, I'm just mapping those across and concatenating them together with pipe delimiters. Okay, I expect the output to arrive in the output.txt file. Let's run this map. Okay, the map completed successfully. The audit log confirms the map completed successfully, but I've got no output. What gives? Okay. It's at this point I recommend you switch to the technique I mentioned and use the count function. Here I have a copy of test1 map called test2. I've got the same 3 input cards, but on the output I've got a temporary structure that uses the count function to count the input objects found. Let's run that map. Oh, by the way, that's the output's going to come into output.txt again. Okay, this map completed successfully. The audit log confirms. But the output count shows me my issue. I've got 7, 1 and 0. Now any 0 sent into a functional map call is going to stop the functional map from being called. The reason I've got 0 is because my input3 file is actually empty. I've got it open in the bottom right there. So let's fill it with some stuff. I've filled it with 3 objects. I've saved the file. I'm going to empty my output file, ready to run the map again. I'm confident this is going to work, so I'm going to switch back to test1 and build and run this map again. Okay, the map completed successfully. But I've still got no output. Okay, looking at the audit log, input card 3 says that I've read 19 bytes. So it's definitely read the input this time. What's going on? At this point, I recommend we switch to looking at the trace. So let's open the trace file there. Let's drag it across to the big window. Okay, we've got input 1 was valid. Let's scroll down. Looks like I may have missed information. Back up. Oh, there, yeah. Input 2 was valid. We've got a lot of information coming out through input card 3 though. It's a bit disconcerting. At the bottom we have input 3 was valid, but it contained invalid objects. Okay, now we're getting closer to the problem, I feel. Back up. Let's find the first error on input card 3. Okay, data at offset 0 stuff. Failed component rule test. Ah, yes, I'd forgotten I'd put a component rule on input card 3. It's expecting the letters OH in capitals as the first 2 characters of each line. So let's put those in now. Over to the input 3 window and add the required 2-character string that is expecting for each of the objects. Let's save that file. I'm not so confident this time, so I'm going to run the map with the counts. Let's see what we get. Run the map. It's successful. Brilliant. We have count, all positive counts, 7, 1 and 3. Okay, let's run the test1 again. Oh, let's empty output.txt first. Yep. Save that. Okay, run the test1 map again. Let's see what we get. Map completed. Ah, excellent. Now we have actual content in our file. Now if you remember, the input counts were 7, 1 and 3. And if you do 7 times 1 times 3, you get the answer of 21. And in my output file it looks like we have the full 21 rows in there. So that's all looking good. Patching TX, as with any other software, comes with a certain amount of risk. Those risks can be mitigated by applying in a test environment first. It is worth pointing out, though, that patches only become effective if the original files are not being held in memory. If, for example, the Transformation Extender launcher or broker is running, locking certain key files. Some platform specifics. After receiving patches for runtime on the AIX platform, for example, you must run the slibclean utility to clear the memory cache. After receiving patches for design time, on a Windows platform obviously, it is recommended to restart the Design Studio. Not with the usual shortcut, but by running the clean extender studio.bat script, which can be found in the product root installation directory. And of course, if all else fails, please reboot your box. There are some additional considerations when running the TX launcher on the Windows platform. The service must be run under specific user credentials if network resources are to be accessed. Service properties can be found in the Services console accessed from the Administrative Tools applet as part of the control panel. Additionally, mapped drives from the current, or in fact any other login session, cannot be accessed by processes started as a service. Where network resources are required, please use the universal naming convention instead. For example, //server, /share, /path, /file.extension. When TX tells you via the input content trace that your XML is not valid, it is sometimes not always immediately clear where the error lies. Obvious errors, such as invalid metadata location, are relatively easy to fix. As the XML gets bigger and the XSD gets more complicated with nested, linked or imported schemas, it all starts to get a bit crazy. Third-party XML checkers take a little while to start up, so it is fortunate the Eclipse design environment comes with a built-in XML checker. From the navigator, not the extender navigator, when you right-click on an XML file, you can choose Validate for a quick yay or nay on the validity of an XML file. For detailed failure information, this is when the third-party validators come into play. They can give you line number and byte offset information about the exact position of the error, and some can even suggest fixes. Let's round off with another demonstration, this time of the XML validation I was just discussing. Okay, we have the map designer open in front of us. We have a project, and in that project we have an input.xml file. Some of these values are not valid according to the schema, but we'll come back to that in a moment. As you can see, if I right click on the input XML file, there is no validate option because you need to be in the navigator view. In the navigator view, right click, there's the validate option. If I click that, it tells me there were 6 errors discovered. Doesn't tell me anything about those errors, but at least it gives me that quick yay or nay on whether that file is valid. As an additional tip, you can switch perspective in the Eclipse Design Studio to the XML perspective and expand your project up on the top left there. You've got your input.xml file, which I shall open again. And then down at the bottom, the problems window will give you more information about those errors. Now this isn't as good as the third-party validators I was mentioning earlier, but it at least gives you some place to start and may help you find the errors in your XML data a lot quicker than maybe using the map trace file would. So Steve obviously is not 146 years old, so I'm going to change that to 46. I right click and validate. It prompts me that I haven't saved the file, so I shall let that save. And now it tells me that instead of 6 errors before, I'm now down to 4 errors. And you can keep doing this on all the errors it finds until your XML is valid again. We'll quickly whip down here, have a look here. Sophie is obviously not 13, she must be 23. And I don't think she started in the company in 1791. That's probably supposed to be 1991. So let's change that as well. And save the file. And right click, validate. Now tells me that the file validated with no errors or warnings. We can close the XML file. we can switch back to the Transformation Extender development perspective and the Extender Navigator and continue on with our mapping. In summary then, functional maps. Match those objects. Adapter connection anomalies. Check usage with online and offline documentation. XML Schema runtime considerations. Is the schema required? -99999 adapter not found and -305 unknown error. Check usage/connectivity and, if required, the JNI log. Unix script ././setup. It has to be done, and it has to be done last. Third-party client software, bitness and the shared library path. Use the tools that are available to check each link. Launcher admin. Run at least once to create that essential launcheradmin.bin file. Adapter appropriateness. Don't use utility adapters for large data. Functional map iterations. Use count and do the math. Patches. Stop processes and clean out that memory. Launcher triggering on Windows platforms. Set the service to start using user credentials and don't use drive letters. And finally, XML Schema validation. Use the Eclipse validator for a quick check. Thank you all again for tuning in to this presentation and demonstration. Please subscribe to my YouTube channel as I will be posting further content. Follow me on Twitter for hints, tips and general news from the IBM Transformation Extender team.